Hello, so I wanted to look at networking today. So see if we can get some basic networking sorted with two different Python programs talking to each other. Okay, so firstly, we've obviously got the basics that we got two computers. And we want to get messages going one way and the other. Now, the way that works is that you have to define one of them as a server. So we've got a server and we've got a client. You can have multiple clients. So we could have another client over here, and that can theoretically connect to the same server. And you may sort of do that if you've got sort of multiplayer game or such like. So you'd have the client connecting up to the server and the other client connecting to the server. And then the server sees those connections and manages them. Okay, so that's what we're creating. So here we've got a server and our client. So that is server, client. So what do we need? Well, we need sockets. Sockets are our key thing here, and there's a module, because there always is, called socket. And we'll need to do that on both sides. The idea is that we can keep things fairly similar across the two, so it's not getting too complicated. Okay, so the server. We can create a new socket and then start listening to it, but let's have a look at the documentation first. So I just googled Python socket and it comes up with the Python documents. And it's talking about socket objects, which we'll look at in a bit. We'll start binding to addresses, and we'll go through all of this in detail. So this is quite low level, we can do all sorts of things that we want. There are probably other ways to achieve it, but this is the basic way that I want you to understand before you go off and do other things. So slightly higher level than C, which is good. Okay, we've got socket families. We're interested in INET, so IPv4, so a host and a port. You should be able to find out the IP address of your computer, and that is what the host will be. We're not too interested in the other ones at the moment. And this documentation contains quite a lot of detail, contains various exceptions and constants. This is what we're using, INET. Where you see something in block caps in the code, it's because it's a constant, and you can look here to see exactly what it means to get a bit more information on it. Okay, functions. This is the bit we want. Creating sockets. Okay, how do we create a socket? Well, socket.socket. Seems simple enough. Family is, by default, is INET, and type is socket stream. That seems good to us. So we should be able to just say socket.socket like that. Okay, where does it? Create a new socket. Okay. So we need to assign that to a variable. So when we create that socket, this new variable is our socket. The next thing we need to do is to get it to listen. Enable a server to accept connections. That sounds useful. So we can just say s.listen. So we're on the server. So it's just going to start listening to commands. So we can. I'm just going to put some print statements in here just so we can see what's happened. I'll print out the actual socket so we can see what we've got. Okay, there we go. So that created a socket, and it's given you some information about it, sort of what the socket family is, the fact that it's socket stream as the default was, and there's no real address for it at the moment. So that's all sorted. We've created a socket. Awesome. Right, the next thing which we need is accept. Okay, socket up. Whoops. Accept a connection. That sounds useful. The socket must be bound to an address and listening for connections. Ah. Have we bound it? No, we haven't. We've listened, but we haven't bound. So what is binding? Here it is. Bind the socket to an address. So before we listen, we need to bind it to an address. Now, the arguments is going to be a pair of values. It's going to be the IP address you're binding on, and I'm not going to put anything. That means it's just going to bind on its own IP. And I'm just going to pick a port. Okay, so that's the port and the IP address, so that means anything, so it's just listening for whatever comes in. And that's the arguments. So the only reason I did that as a separate thing, so you could see that it's not just the values there, it's actually a pair of values. Okay, so we're bound and listening. One thing which is worth mentioning at this point is that we can also set the options on the socket, and there's all sorts of things on here, but one really important one which I think you need to be setting, otherwise you'll just end up with all hiccups, is SO reuse address. This is getting it so that you can connect multiple times. Not at the same time, but when you connect, let's go back to our diagrams, when you connect from the client, if the connection dies, then that's going to stay there. Then another connection is going to try and come in, and it's not going to manage because that connection is already in place. Or even from the same place, it's going to say, hang on, nope, there's already a connection, can't do it. This is because this is in a waiting state. If we get rid of this waiting state, as soon as the connection is terminated, oh look, there's another connection coming in, I've got one which is waiting, but we'll ignore that and let the new connection come in. So we can actually see what the documentation says about this. Tells the kernel to reuse the local subject in time wait state. So it doesn't wait for it to time out and finish and say, well, this connection is obviously dead. It will just say, okay, we got a new connection. Okay, and we've connected the socket. So the next thing we want to do is actually accept any connections. Accept a connection. The socket must be bound to an address, done that, and listening, done that. The return value is a pair, con and address, where con is a new socket object. Okay, so we can put in a new socket, and an address, and it's just s.accept. There we go. And I'm just putting a print here. Got a new connection from, and this is where address is saying where the connection is coming from. So if you think about it, the server here has created a socket. It's open and accepting connections. It doesn't, or rather your program needs to know whether the connection is coming from here or whether it's coming from here. And then you can do whatever you want with it, really. You can assign different things to different users, whatever. It's an identifier to say where it's coming from. Okay, let's run that, see what happens. Okay, so that's saying that it's created a socket. Awesome. But it's not saying it's got new connection, and it's just sitting there waiting. And that's because this is a blocking command. Your program will not go past this point until this has done something. It's just saying, okay, wait there until you get a connection. So it's just sitting there waiting and waiting. Okay, so let's have a look. We've created a socket, we've set it to reuse, we've bound to a port, and we're listening for connections. We're then just accepting new connections. Okay, now let's look at the client. The client, we kind of need to start with these ones. Exactly the same there. We're using sockets just the same, we're reusing the ports just the same. The difference is the socket we can then connect to the server. Now you should be able to find out the IP address of your other program. I'm using it on the same computer. That means, and don't forget we've got a pair of values, hence the brackets again. If you're on the same computer, you can use the loopback address, which is that, and then the same port as we're using over here. Now the loopback address, any computer, it has a network adapter which just goes back to itself. So it's the loopback, so it can always, in networking terms, contact itself, and that is 127.0.0.1. That is a reserved IP address. If you try setting anything else to the IP address, it will just throw all sorts of hissy fits. Okay, so that's connected, so we can say print connected. I'll even do S just to see what happens. Okay, next thing is sending. Actually, let's just run that. So we've got this one which is waiting for the connection, running the client, and it doesn't like it because this needs to be a string. There we go. Awesome, so there we go. It's got a new connection from localhost, and this one set up connection. It then finished because, well, we got no more program. That, so far, I think is a success. Now, what we want to be doing on this side is sending something. Now, we can just send hello. However, it needs to be bytes rather than a string, so we need to encode it. So any string, we can just do .encode, and then we can see what that will do. So we need to, we've accepted. What we need to do is listen for an actual message. So that the command for that is receive. Receive data from a socket. So let's have a look at that. New sock. So that's the new socket which has been created. There will be a new one of these from each connection, so you could be running this command multiple times and creating a whole load of sockets for the different clients. But each of these sockets, they're slightly different from these sockets, confusingly enough, is for one connection. And we can say receive, and how much data do we want, and then that is, unsurprisingly, going to be returning something. So we can just print it, see what happens. Now it's sitting waiting for a connection. Now this one is connecting, sending it, and there we go. We've got bytes and the message. So that's sent it over successfully. We can do decode in order to make sure that it's the proper message. Awesome. Now we can do things like this, and we can do an input statement. Message equals input message, and then instead of encoding hello, I'm going to encode mess, and again I can put this in a while truly. So now I've got two programs. I've got the server which is sitting there, I've got the client which is connecting to it. So it's got the connection. It's not received anything, so again this is a blocking call. And I can send messages over. Lovely. This is all one way. It's worth noting this is a socket, so what you can do is send it in exactly the same way. Encode that, and then on the other side we can receive. So we're going to reply, which is that. Note that it's now going to be waiting until it receives a reply. So if we got a server which doesn't then send a message in reply, this will just hang there forever. But anyway, let's have a look at this program. So this is saying message, it's got a new connection, it's waiting. We can send a message, hello, and that's printed it. It's not sending a reply. Okay, what's going on here? Has that center this? Put a print at the end. So we got that. Hello. There we go. I think I probably didn't save it or something. So it's send a reply. So you got the message, and then it's just saying hello, thank you for reply. We could change this to an input statement. So it's a two-way communications, and that would be a good first step. So that's your basics of networking. What we'd need to do in order to get this into a decent program is start doing a bit more threading. And so we'd be able to have one thread which is just accepting connections, and then another thread which is receiving messages, and maybe even another thread which is sending messages. It depends how your program is set up. But this is the basics, and you should be able to send things back and forth in a very, not restricted, but a very regimented manner. The messages have to be in the correct order, that it has to be the correct things that it's waiting for. Anyway, I hope that's of use. Best of luck, see what you can make.